Hello everyone, we're going to start the second part of this organic chemistry. This lecture is going to be quite interesting because we're going to deal directly with the organic compounds, and here are the details of the compounds that we are going to study, which is also included in your syllabus. So you can see over here that the almost 7 organic compounds are there, the types of the compounds are there that we're going to study, and we will also try to understand how to name this. So the first is hydrocarbon, which is basically three types: alkane, alkene, and alkyne. And then alcohol group is there, ketone, carboxylic acid is there, aldehyde is there, ether, and halides group, which is fluorine, bromine, iodine. Specifically, these four elements that we're going to talk about. So in this lecture, we will discuss this hydrocarbon first. But before understanding this hydrocarbon, I will tell you we should go ahead and understand the behavior of carbon first and how we can use the prefix or the suffix while naming the compound. Basically, naming is a nomenclature is there, which has been decided by the IUPAC, that is the International Union of Pure Applied Chemistry. They have decided that how to name. They've published rules for this. We also call this blue book, which says the pattern how to name the organic compound. So whenever this carbon length is coming, like sometime you'll find the carbon chaining C1, C2, C3, like this it will go. So how we will name this? Here this table will help us to understand how we can name the carbon chain whenever there is a different number of carbons are there. So whenever one carbon is there, we will call it methane, meth. And whenever there is just two carbon is there, we will call it eth. And 3 is a prop, 4 is a but, 5 is a pent, hex. In this way we're gonna go. It has rarely happened that more than 6 or 7 carbon atom you're gonna find in a chain in your syllabus. So mostly question comes from the 1st to 7th, or sometimes 8, not 9 and 10. They don't make it more complex, but we will understand. We will keep this in our mind, in our memory. Whenever these word is coming, they are basically prefix. Like we can say this carbon atom over here. You can see which is having 6 proton and 6 neutron over here, which we will not actually deal with this proton and neutron, just we need to have the idea of electron over here. So you can see the electron in this case. In the first shell there's 2 electrons are there, and the second shell you can see the 4 electrons are there. Okay, so 4 electron, that means these 4 electrons are being ready to shared by carbon in order to get the octet state. So what will happen, suppose the carbon is coming in the contact with the hydrogen, with these 4 electrons, and this hydrogen is coming with 1 electron at the last shell, like this you can see, like this you can see, and like this you can see. So they will share in this way, they're going to share in this way, they're going to share in this way, and they are going to share in this way. So this will form C H H H H. This line you can see, it is representing the covalent bond. So here the formation of CH4 happened, which we call methane. Now you can see this one, there is only one carbon, so we will call meth. And ane, why we are calling ane, we will understand later. Okay, so you can see the formation of methane over here. The carbon is having 4 electrons, which is ready to share with the hydrogen, 4 hydrogen, and form in this way. So we have understood that the carbon got the 4 hands which are ready to satisfy, which is ready to being attached to any other material that is coming in contact, or it may be not coming with any other material, though it may will come in the contact with another carbon, it will create a chain like this. Okay, so here we're going to understand the hydrocarbon first. Let's see this one. Hydrocarbon, we're going to understand this one, and here we have fragmented into the different categories you can see. So hydrocarbon, basically CH, has been fragmented down into 2 categories. The first is open chain compound, and second is a closed chain compound. What is open chain compound? That you're going to find carbon like this. they are always like maybe in the linearly they will find they will make the kind of structure, or they may have the branch structure like this. Okay, so these are the open chain. They are ready to get attached with any other material that is coming in the contact. Okay, so we also call this aliphatic. Remember the name. Instead of saying open chain compound, we also call aliphatic. Okay, that means the open chain. And second one is a closed chain compound that you're going to find. We also call this cyclic chain compound. Remember this one. So why this is cyclic? Because the carbon is cycled in this way, means they are closely bounded in this way, or maybe 3 or maybe 4. So whenever there is at least 3 carbons in the closed chain compound, so we will call alicyclic. Okay, and whenever there is a carbon in a closed compound, at least one containing benzene C6H6, so we will call aromatic. This closed chain compound is not included in your syllabus, but for kind of information you can have in your memory, you can have in your concept. Okay, now let's move to understand this open chain. So you have understood basically open chain is something like it may be a linear structure or maybe branch structure. And open chain has been divided into 2 categories. The one is saturated, another one is unsaturated. What is the meaning of saturated over here? And what is unsaturated? So whenever you're finding this carbon associated with the another carbon by the double or triple bond, we call unsaturated, because these bonds can be loose by between the carbon and can be attached with any other material. So that will be unsaturated. But here you'll find only single bond between the carbon, so it is saturated. Why it is saturated, we will understand in very deep. Let's see this one. First, I'll understand the alkane. So alkanes is basically saturated open chain hydrocarbon. So basically, we also call this alkane is a paraffins. Remember why we call this paraffins? Because alkane makes highly inflammable liquids. So like kerosene is there, okay, a diesel is there. So these kind of things they form by the alkanes. So alkanes are basically we call paraffins, and the formula of alkane is CnH2n+2. Remember, this is a very important formula to understand which one is alkane. For example, I'm giving you just one example. You can see this C3H8. It is satisfying this formula or not? Yes, it is satisfying. You can see instead of 3 we can say N. So I'm just writing 3, and I'm just writing in the form of this formula 3 into 2 plus 2. So this is going to be 3 into 2 is 6 plus 2 8. So this is basically alkane. We can take a very basic alkane example is CH4 methane. Now you can see the word, I was saying meth for one carbon and anes for this alkanes. This suffix you are seeing over here, we will use this alkanes. Okay, so we're going to say for one carbon this is meth, and for this ane we will write ANE, methane. Okay, so you hope you understood this IUPAC name, IUPAC name. Now we're going to understand this alkenes. What are the alkenes? We call olefins. Why we call olefins? Because the alkene reacts with a certain halides group and forms the oil type liquid. So that's why we call this olefins. Okay, the formula of alkene is CnH2n. Okay, now we're going to understand the alkynes. What is the alkynes? Alkyne basically a carbon compound, a hydrocarbon compound which contains the carbon and hydrogen in this order, NH2n-2. So if any hydrocarbon compound that you're seeing is satisfying this formula, so we can say it is alkenes or alkynes. Or not just in this way, whenever you'll find in a structure like 3 bond you're finding between 2 carbons, so it is alkynes and whenever you're finding double bond between the two carbon, it is alkene. Most of the time what will happen, you'll find the mixture of these two or mixture of these three. So keep in your mind, we will discuss this one in a very detail. Whenever what happens, when you remove just one hydrogen from alkenes, it becomes alkyl group. This is also very important because many times we will find this kind of category of the hydrocarbon in the chain, and we have to name this. So we call this alkyl group. When you remove one hydrogen, you can see over here the formula is CnH2n+2. We call this alkanes. Okay, when you're removing one hydrogen from here, so the formula will become CnH2n+1. Okay, for example, you can see CH4 is there. When you remove one hydrogen from this, so it's going to be CH3, and we will call this methyl. Remember this name, this suffix that you're seeing over here, we will use this. So for one carbon it is meth, and this yl, methyl. In the same way we will remember this yen, okay, and ene, enes. Okay, let's see the first alkynes in a very detail. We were going to discuss about this one. Sorry, alkanes, Alkanes, alkanes. We're going to discuss in a very detail. Let's see this one. The formula, as we discussed, it is CnH2n+2. Okay, let's take the simple example. Let's take the simple example of this one is C2H6. Now let's just start drawing this structure, the molecular structure of this formula. What will be the empirical formula of this one? So it will be CH3. Empirical formula will be CH3. This is the molecular formula. Now we're going to draw the structure, chain structure of this C2H6. Try to name this one first. C2H6. What it will be? 2 carbon is there. So for the 2 we use eth, and you can see it is alkanes. So we will say ethane. The name will be ethane. Okay, let's draw the structure. So we can see 2 carbons is there, and we know alkanes are basically bind with the single covalent bond between the carbon. So we were just writing 1 carbon. Okay, now here the 4 hands are there. Each carbon has the 4 hands. So I've written like one hand, you can see it is being shared between the 2 carbon. So this hand for this carbon also, and this hand is for this carbon also. Now you can see three hands are free of each carbon. So here you can see total H6 is there. So we can add 1 H over here, 1 H over here, 1 H over here, and we can add 1 H over here, 1 H over here, 1 H over here. So you can see total carbon is 2 and hydrogen total is 6. So this is the basic structure of alkanes. You can see it is a single bond between the 2 carbons. So we will call this alkanes. Okay, let's try to name this one. C4H10. Let's try to name this one. What we call this? C4. For the 4 carbon, whenever there is a 4 carbon, what we call this? We call but. B-U-T. We write it but actually we call but. Okay, let's see this. So where is the alkanes I have written? It is down below. Okay, C4H6. So we call this but whenever there is a but. Okay, so we call this but. Okay, now how we will name this one? It is but. You can see but. So we can write in this way. You can write in this way in this formula. Okay, 2 into 4 plus 2 we have added. Now this will be C4H10. So it is satisfying this H10. It is satisfying this alkanes formula. So we can say ane. We're going to use ane as the suffix. And for the prefix, we use the number of carbon. The carbon is 4, so we will say butane. Okay, try to name this one. C5H12. So carbon is 5, so we will say pent, and this is alkane because the single bond is there, so we will write pentane. Okay, try to name this one C3H8. So you can see 3 carbon is there, so for 3 we use prop, and it is alkane, so we will use A and E, propane. The name is propane. Let's draw the structure of propane. Let's draw the structure of propane. This is the 2 carbon you are seeing, and this is propane basically. So for the prop we're going to use 3 carbon and ane, so that means each carbon will have all the carbon will be associated by the single bond. Okay, now here you can see this carbon got the 4 hand. This carbon is a specific carbon already having 2 hands, so we will give just 2 hands. And this carbon you are seeing over here already is having 1 hand, so I'll give. Now you can see each carbon having 4 hands. Now here this and this already is being shared between these carbon, so we will not attach any other material. And this is propane, by the way, so hydrocarbon, so there will be only hydrogen and carbon, so we have to attach the carbon over here. So we'll take the hydrogen over here, then hydrogen over here, then hydrogen over here, 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 and hydrogen over here. So you can see total is C3 and total carbon is over here 8H8. Hope you understood this idea of alkanes in a very detail, how we will name the substances. When we go ahead, we will understand little by little, and in this way we will proceed further. Okay, we're going to understand the next one, which is alkenes. That is alkenes, A-L-K-E-N-E. Okay, so this enes is very important. Let's see this one. What is the formula of alkenes? We also call olefins. Okay, the alkene formula is CnH2n, just double. Whatever the carbon will be there, you'll find the hydrogen is just getting double. So we'll start from the very basic. It is start from the actually 2, CH2O. Okay, you can see this this carbon, 2 carbon is there, and you can see over here that if it is alkenes, that means it's going to be double bond, okay, between the carbons. So I've given the double bond. So you can see this carbon got the only 2 hand, and this will also having 2 hand, because the 2 bonds, 2 hands already engaged with the another carbon, and this carbon in the same way. Okay, so how much hydrogen we can attach? How much hand remains? Just 1 hand remain. This and this, this and this. Now you can see the formula will be 2 carbon is there, so 2 carbon we will write, and total hydrogen is 4, so 4 we will write in this way. Now it is clear what we will call this. It is eth, because 2 carbon for eth, and we will call ene. Remember one thing, in alkenes it is impossible to make alkenes with single. So methene is not possible. Remember this one, methene is not possible. Why it is not possible? Because whenever you are making any alkynes group, alkyne group, that means you have to have a double bond between the 2 carbons, and for a single carbon it is not possible. So simply we can say methene is not possible in the case of alkynes. Okay, let's see this one, another example for better understanding. We will take another example like C3H6. Okay, first try to name this one. How many carbons are there? 3 carbons. So for the 3 carbon we use prop, and this is alkyne group because just hydrogen is getting doubled as a comparison to carbon number. So we will use this propene. Propene. Hope you understood this. Propene. This is carbon is 3, so for the carbon 3 we will use prop, and hydrogen, you can see this double bond, basically alkenes it is there, so we will write enes at the suffix. Okay, so the name will be propene. Propene. Let's see this one, how we can draw. Here you will find a little confusion. There has to be double bond between the 2 carbons like this. So actually no, we don't need to have a double bond over here. just one carbon will be single double bond will have, and another may have the double or not, that doesn't matter. But means at least one carbon, two carbons, between the two carbons you will find at least double bond. So that's really important to understand. Okay, now how we'll name this one. Let's see this one, how we can name. You can see this carbon is already engaged, two hand has been engaged, so two will remain, and this carbon is having just one, so one I've given, and this carbon already also having 2 and 3. So you can see hydrogen I can attach over here. One hydrogen I'm attaching, H, then H, then H, and then H, H. So total is basically 6. So we will write C3H6. Hope you understood this, how we will draw the structure of alkenes. Remember, whenever this double, whatever the number of the carbon is there, when the hydrogen is just getting doubled, we will say it is alkene. Okay, so this is quite interesting to understand. And one more thing that you must remember, that methane is not possible, because alkene says this, there has to be double bond between the two carbons, and for the meth there is only single carbon, so methane is not possible. Okay, now one more thing you should pay attention is they are unsaturated, like I've said when I was categorizing the hydrocarbons. Why they are unsaturated? Suppose what will happen if I'll bring the ethene like C2H4 and I try to react with the hydrogen, so it can form C2H6. C2H6. What will happen over here? This bond that you're seeing between the two carbons, double bond, it will break down and will create further hands in the two carbon. Now remember, whenever the bond is being shared between the two carbon, actually they are the common hands, and when we are breaking it, so they will have an individual hand. Now they are ready to attach with the another hydrogen. So you have seen what it is, alkene. This is alkene has been changed into alkane. Means it was unsaturated, becomes saturated. So idea I think has to be clear over here, because saturation means it is no more carbon cannot further attach with any other hydrogen. So alkanes, you can see it is completely saturated, it got no hand that can attach with the further hydrogen. But in the case of alkene, you can see that two bonds were attached between the two carbons, so this bond can be broken down and make a further hands in the carbon which will attach with the further hydrogen. So hope the idea is clear over here. What is the alkene and alkane, why alkene is saturated, unsaturated, and alkane is saturated. Let's see this one, the last one we're going to understand, which is alkynes. Okay. Alkynes. The formula of alkyne is, whatever the number of the carbon atom will be there, we have to double the hydrogen and subtract it 2. This is the idea. So let's take a very simple idea over here, C2H2. It is, let's start naming this one. This is a 2 carbon you are seeing, so it will be eth, and this is alkyne, so we will use this YNE, so the name will be ethyne. Okay, let's see this one, how we can draw this structure. By the way, what will be the empirical formula of this one? So it will be CH only, remember. Okay, let's draw the structure. So there is a 2 carbon, so the alkyne it is there, that means it is a triple bond hydrocarbon. At least 2 carbon will have triple bond. Now you can see that this carbon got the 3 hand, this carbon got the 3 hand, so means 1 hand and 1 hand left, and this one hand will be occupied by the hydrogen. So you can see 2 carbon is there, so I've written 2 carbon and 2 hydrogen is there, so 2 hydrogen, C2H2. Let's take the another example. What about the C3H or C3H4? Okay, Let's draw the structure. First, try to name this one. Try to name IUPAC, International Union of Pure Applied Chemistry. How they done the nomenclature. Try to name this one. This carbon is 3. For the 3 we will use prop, and you can see it is ine group. Okay, so we will write YEN. Okay, propine. Now let's draw the structure. Carbon is 3, so we're going to take, like we have understood in the alkenes, so there would be double carbon bond was there. So here we 2 carbon will have the 3 bonds, not necessarily to have the over here, and it cannot have, because you can see over here this carbon is already having 3 hands over here. So how it is possible it will attach with the another carbon with the 3 hands? So it is not possible. Okay, now keep in your mind that this carbon here is this carbon is specifically this carbon complete their last shell with these 2 carbon. You can see the 4 hand is there. This carbon got the 3 hand this side and 1 hand at this side. Hope you understood this. Okay, let's see this one. How many hands this carbon left? So this carbon left the only 1 hand, and this carbon left 4 hand, you can see, and this carbon got the no hands because already attached with these 2 carbons. So if the carbon hand is being left, so we have to give the hydrogen, fill it with the hydrogen, because it is hydrocarbon. So that's why we are filling with hydrogen. Okay, now you can see how many carbons is there. 3 carbons and 4 hydrogen. Okay, so we will call this alkynes. Remember, alkynes. Whenever you find the carbon hydrogen composition in this pattern, so we will call this alkyne. Hope you understood this alkene, alkyne and alkanes. You have understood why we call saturated, unsaturated. Here we can take the example over here also, like if you will react the C2H2 with the another H2, so this is going to be C2H4. So you can see what will happen over here. This bond that you're seeing between the 2 carbon will be breakdown, and will create further hands in this way, which was already attached with the hydrogen, and this C2H2 is reacting with the 2 hydrogen, so we can add up the 2 hydrogen over here. So you have seen that it was unsaturated. We further added up the 2 hydrogen, and now it becomes the alkenes. And now when you will add further 2 hydrogen in this alkene, then it will become alkane. Simple idea is there. So what we have understood, what we can conclude from here. So conclusion is basically whenever there is an alkane is there, okay, and alkene is there, or alkyne is there, when you remove just 2 hydrogen from it, 2 hydrogen from alkane, then it will become alkene. When you remove 2 hydrogen from alkene, it will become alkyne. So you basically removing, so it is saturated is becoming unsaturated, and further it is becoming unsaturated. Now you have to add, when you add this 2 hydrogen, then alkyne will become alkene, and when you are adding 2 hydrogen in alkene, it will become alkane. Remember this one. So these unsaturated are becoming saturated. So these are the idea from this lecture. In the next lecture you are going to find the MCQs related with this lecture. Thank you so much, and keep watching my channel. Please do subscribe my channel.